Hi everyone, welcome to my video on GCSE Maths. We're going to look at tree diagrams. This is also useful if you're doing GCSE statistics or even A-level statistics. I think tree diagrams are one of the most useful things in maths. What they do is they can analyse different situations where there's more than one thing going on and more than one possible outcome. So let me just make up a crazy example so that you can try to understand what they're doing. Okay, so let's say you've got your weekend coming up and it's Saturday and you were thinking that you might do homework Saturday morning. Okay, and your friends texted you or contacted you on Facebook saying, do you want to go shopping in the afternoon on Saturday? Okay. Now, you've got two choices, one for the morning, one for the afternoon. And you're not sure what you want to do. And it's Friday night and you're going to sleep and you're thinking, okay, well, I'm kind of thinking about not doing my homework, to be honest. So let's say that the probability that you do your homework is going to be just 0.3 because you don't really think you're going to do it, but there's still a chance if you wake up feeling really keen to do your work. However, if you're doing your homework, the only other choice is that you don't do your homework. Okay, you either sit down and you try and do it or you don't. So probability of not doing homework, we'll have to add it with 0.3 to make 1. Okay, let's say that you're really keen on going shopping. So the probability that you go shopping, we're going to call it 0.9. Now the only other option is that you don't go shopping. Okay, you're either out shopping or you're not. So the probability that you're not shopping is 0.1. They add up to 1, 2. So how does a tree diagram work? Well, what a tree diagram says is in the morning you've got two choices. First choice is doing homework. Second choice is not doing homework. That's up to you. Okay? Now on the second, in the afternoon, you could have either done your homework or not. Let's say it's independent. It's not going to affect whether you go shopping or not. Let's assume. Okay, maybe it would in real life, but this is a maths question and we're not going to worry ourselves on that too much. So the choices for the afternoon are obviously that you go shopping or you don't go shopping. Okay, two choices there. Now the thing is, before we've started the stuff, we do not know if we've done our homework or if we've not done our homework. Okay? So we need one option for if we've done our homework and one option for if we've not done our homework. So this is our first tree diagram that we've looked at. And what you can think is that you're here waiting to start your day and you've got two choices. You could go down the homework route or down the no homework route. Okay? Once you move to here, if you do your homework, you've got two choices again. You can either go shopping or not go shopping. Okay, so there's 4 different options: homework and then shopping, homework then not shopping, not homework and then shopping, or not homework and then not shopping. So you've got lots of choices, so you're a happy person there. Okay, so how does maths come into it? Well, the maths comes into it because we should know that we've got those 4 choices. What the maths does is it tells us the probability that we're going to select a certain choice. So if we wanted to know the probability that we do our homework and then go shopping, we're walking along these branches, and the maths that we're going to do is we think probability of homework was 0.3, the probability of shopping was 0.9. Okay, And if you want to do the probability of homework and, notice the word and here, shopping, you're going to multiply. Okay, so probability of homework and shop is going to be 0.3 times 0.9. Okay, which is going to give you 0.27 as a probability. So as 0.27, 27% chance that you're going to be the guy or the girl that does the homework, then goes shopping. Okay, so let's look at one other option. Let's look at being a bit of a rebel, not doing your homework and refusing to go shopping. Okay, I know the line's gone a bit dodgy there. So probability of not doing the homework has to add up to 1, so 0.7. And the probability, we said it's independent, it's not going to change based on what we did before, so it's 0.1 down here. So the probability of you being a rebel, not doing homework and then not shopping is 0.7 times 0.1, which is 0.09. Okay, now it gets interesting when you start asking questions like, what is the probability that you do homework and go shopping, or do no homework and don't go shopping? Because of the or word, when it was and we multiplied, when it's or, it gets more likely we're going to add. So that would be 0.27 plus 0.09, so probability of homework and shopping, or not homework and not shopping, would be those two added together, which would give you 0.36. Okay, so that's my intro into tree diagrams. Now the really cool thing about tree diagrams is you can use it even if things don't happen one after the other. Okay, so let's think of an example where that might happen, where it's not one after another. You could have a bag, okay, and you could have, I don't know, 3 blue balls, 2 green balls. You know what, you can have 3 options and then you have 3 lines coming out, but I'm going to stick to this for now. Okay, so we want to say we're going to pick 2. Okay, this can be done on a tree diagram. You can think of, it might be done at the same time, but you can think of one pick happening before the other one, even though they happen all at once, if that makes sense. Okay, so the first pick, you can either get blue or you can get green. Okay, the second one, same again, you can either get blue or you can get green, and that's the same for both. Okay, now this one, the probability might change a little bit. Let's imagine we take out our first ball, and let's say we take out a blue one. The probability, there's 1, 2, 3 blue balls out of 5. So it's 3 out of 5 chance that you get a blue ball. Now we know this one's going to be 2 out of 5 because it adds to 1, but also because we can see it here. So remember what happens when our guy walks along to here. That means you've got a blue ball. So that blue ball's out the equation. So now the probability of getting blue is 2 out of the 4 that are left. I know it simplifies to half, but that's not what we're focusing on this video. Okay, and the probability that you get green is 2 out of 4. Let's look down below. When we take out, let's say we take out a green one first, we go along this track, we take out a green, okay, so that's gone. So now the probability of getting blue is more likely, there's 3 blues out of 4, okay, and for green there's going to be 1 left out of 4. So that's your tree diagram filled in, which you usually get a couple of marks for in your exam, and I will be doing exam questions once I've finished this example. Let's say, what is the probability that you get one blue and one green. Okay, so we have to think here. Highlighter would be good in your exam, to be honest. Think which lines you can go down. You can go down getting a blue and then a green. Okay, or you can go down getting a green and then a blue. Notice I said the word or. Little trick for you. Along the lines, you're going to do multiply. And at the end, going down, you're going to do add. Anyway, as we said, blue and green. It's going to be, oh, let's do a little probability thing. Blue and then green. How cool are pictures? Okay, blue and green. 3 over 5 times by 2 over 4. You guys are good at timesing fractions by now. That's going to give you 6 over 20, aka 3 over 10. Is that right? Yeah, I think so. 3 over 10. Okay, for that one. The probability of getting a green and then a blue. Okay, green and a blue. Is going to be this times by this. Because you've gone the green and then the blue. So it's 2 out of 5 times 3 out of 4. Now something quite cool is going to happen here, I believe. You're going to get 3 out of 10 again. And if you notice, the reason is it's the same numbers going on. Okay, and the same ones are on the top and the bottom. That's all that matters. Multiplying the divides. Right, so we've got 3 out of 10 for this, or, so we add 3 out of 10 for this. Okay, so the probability of getting blue, green, or green, then blue, equals 6 out of 10. You add them together, which is 3/5, I know. But that's fine, okay? And that was originally a wordy question, okay? And remember I said it doesn't matter if you're actually picking them both out at the same time. You can still visualize it like this, okay? Which is pretty awesome, I think, anyway. Let me know if you agree. Moving on, some exam questions. Okay, so this is what they're actually going to look like. I hope I've made this big enough for you to be able to read. Going to highlight, read it out anyway, so if you pay attention, it won't matter. Emma has 7 pens in a box. 5 of the pens are blue. Now, if you've watched my videos, you'll know I like to draw lots of diagrams. So there's 5 blue pens. Okay, and 2 of the pens are red. So now we've got a visual of what's going on. Emma takes, at random, a pen from a box and writes down its colour. She puts the pen back in the box. Important bit here. So what we're doing, we take one out, look at it, put it back. Okay? So there's always going to be 7 pens in the mix. Right, the probability that she gets blue at first is 5 out of 7 pens. Probability that she gets red at first is 2 out of 7 pens. Okay? Because we put it back again, because we replace, it's going to be the same probabilities for blue and red again. Okay, so that's a nice couple of marks for filling it in. Work out the probability that Emma takes exactly 1 pen of each colour. Okay, 1 of each colour. Very similar to what we've just done. Okay, so let's think about blue then red, and red then blue. We do not want blue then blue, and we do not want red then red. Okay, so it's these two. For this one, 5 over 7 times 2 over 7. Let's move this out of the way for now. Is going to be 10 over 49. Now, I'd never simplify these because when you add them, you want the same common denominator. And you notice I did that before as well. 2 over 7 times 5 over 7 this time. You can see that's going to be the same. Okay. So we want that or that, so we're going to be adding 10 over 49 plus 10 over 49. They're already the common denominator. 20 over 49 is the answer to the posed question. Okay, happy with that? Next one then. In a game of chess, a player can either win, draw, or lose. I know that too well. The probability that Vichy wins any game of chess is 0.5. So you can see that here. And it said any game of chess, so let's put all the wins as 0.5. Okay. The probability that Vichy loses, sorry, I've read it wrong, draws any game of chess is 0.3. It's already on for us here. Let's add it to the others, because we're going to assume that they don't affect each other. In real life, you might be affected if you just lost a game. You might be upset and you might not do as well. But this is a maths question. Let's just go with it. She plays 2 games of chess. It's drawn the diagram for us. I told you don't always have 2 options. You could have 3, even 4, even 5, whatever. Okay? But then you'd probably want a computer to start doing it for you instead of you. Work out the probability that she wins both games. Okay? Win, then win. So, what we want is we want to fill in the tree diagram, because that would actually be part of the question for 2 marks. This adds up to 0.8, so the missing one in each case is 0.2. So that job done. Now let's get on with the posed question. All we want is a win, then a win. That's all we ever want, isn't it? It's a win in life. Anyway, so probability of a win, then a win. It's 0.5 times 0.5. Okay, aka half of a half, aka a quarter. 0.25, 25%. Okay, so it's quite a nice one because we only had to consider one scenario. Next one. Matthew puts 3 red counters and 5 blue counters in a bag. 3 red, 5 blue. You know what I'm going to do. It's going to be a diagram. 1, 2, 3 red, and 1, 2, 3, 4, 5 blue. Obviously, we'd shake up the bag a bit, make it fair. He takes at random a counter from a bag. Fair enough. He's going to take one out. He writes down the colour and he puts it back again. Okay, so it's not like the one I made up before. He's always keeping this same number of items in the bag. He then takes at random a second counter from a bag, so he's picking out 2. The probability that he picks out a red is 3 out of 8, and it's told you that. There's 8 counters, 3 are red. Probability of blue is the rest of them, 5 out of 8. That is the same whether you pick a red out first or a blue out first. Okay, it doesn't affect it. Work out the probability that Matthew takes 2 red counters. Okay, probability red and red. So let's look at the route that we want to focus on. The route is up to red and up to red again. So it's going to be 3 over 8 times 3 over 8. Okay, and that's only one situation. It's not an or, so it's a bit of a boring one. 9 over 64. Next one. Tom and Sam each take a driving test. The probability that Tom will pass the driving test is 0.8. So that means, look, you can see Tom is this column, Sam is the next one. I told you it doesn't have to be time related. Okay, it can just be 2 different events. Probability that Tom will fail is 0.2 because you either pass or fail your driving test. Okay, probability that Sam will pass is 0.6, so the probability he fails adds up to 1, 0.4. Work out the probability that both Tom and Sam will pass the driving test. Okay, so this first one, probability pass pass. So let's look at the route we want to travel. Do it in highlighter. We want to go pass, pass. Very much like what we did before. So probability of a first pass is 0.8. Probability of the second one is 0.6. So you think about 0.8 times 0.6. You can think about 8 times 6 and then move decimal place. It's 48, so 0.48. By the way, this will never go above 1 because it's a probability. So that might help you with multiplication. 0.48. Next one, write down, work out the probability that only one of them will pass the driving test. So that means you can get a pass from Tom and then a fail from Sam, or a fail from Tom and a pass from Sam. So let's look on the routes, the ones that we're interested in. It's going to be a pass and a fail, or a fail then a pass. Okay, so it's going to be 0.8 times 0.4 for the first one, which is going to give you, well, 8 times 4 is 32, so it's going to give you 0.32. Next one is going to be different here, 0.2 times 0.6, so don't expect the middle ones to be the same, which is 0.12. Okay. Right, because it's or, we're going to be adding these two things together. So add in your columns 4, 0.44. Simple as that. I think you'll quite like tree diagrams when you get used to them. Next question. I like this question because it doesn't give you the diagram, but it is sweets in a bag again. Very common question. So there are 3 orange sweets, 2 red sweets, red, red, 5 yellow. I hope you can see the yellow okay. 1, 2, 3, 4, 5, and 3 orange. How are we going to do orange now? Can we mix? Let's grab an orange here. 1, 2, 3. Okay, 3 orange, done. So, how many options do you have? A red, a yellow, or an orange? So 1, 2, 3. Okay. I would advise you not to draw these too big because you'll see that the 3 ones get quite big. So I'm going to just make that a bit smaller. So first option was orange, red, yellow. So we've not even finished reading the question, have we? So let's do that first. Sarah takes a sweet at random. She eats the sweet. Classic. That's exactly what I'd do, to be honest. No chance I'm putting a sweet back without eating it. She then takes another sweet at random. So the first time it's out of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so all your probabilities are out of 10. Oranges, we've got 3 out of 10. Do not worry about simplifying. Red, 2 out of 10. Yellow, 5 out of 10. Okay. Now when we eat it, it's going to change, and there's going to be, depending on which one we eat, there's only going to be 9 left. Okay. So the next ones are going to be out of 9. Right. We need 3 choices for each. It's a right mess. As long as you can follow it yourself, that's the main thing. Okay. Right. I'm going to be efficient here. I'm not going to finish filling all this in. I'm going to read the question, see what's required. Okay. Now the options here are orange, red, yellow. Orange, red, yellow. Orange, red, yellow. And if we've already picked an orange out, if we want them both the same, the only path that we're interested in is orange then orange. Okay, so let's just think about that one. We've taken an orange out, so there's 9 sweets left, and 2 of them are orange because you've eaten 1 of them. So that's 2 out of 9. Yes, I know we can do the others. 2 out of 9, 5 out of 9, but we don't need to. We don't need them in the question. So there's no point making extra work. Next choice is red, then red. Okay, straight across. So once you've eaten one red, there's still 9 sweets left, and the probability that one of them's red is 1. There's only one left. Next choice is going to be yellow, then yellow. Why does it keep doing that? Yellow, then yellow. Okay, well, if you eat a yellow, there's 4 yellows left out of 9 sweets. So let's do the probabilities. We're going to multiply across the rows and then add. So 3 out of 10 times 2 out of 9. 3 over 10 times, can I move my bag of sweets? Disaster. Sorry about this. Sweets everywhere. Put these back in the bag there. Okay, 3 out of 10 times 2 out of 9 is going to be 6 out of 90. Do not simplify, you'll see why. Okay, next one, 2 out of 10 times 1 out of 9 is 2 over 90. I've already multiplied, sorry, I'll show you what I did. 2 over 10 times 1 over 9, 2 over 90. Next one, 5 out of 10 times 4 over 9 is going to be 20 over 90. So why haven't I simplified? Well, because now they're all over 90. We can add them easier. So it's orange and orange, or plus red and red, or plus yellow and yellow. Now, because we've kept them all the same, just add your top numbers. We've got a common denominator. That's going to be 28 over 90. And that's your answer. Okay, I'm not sure if there are any more. Let's just check. Yeah, I think this might be the last one. So that was quite an interesting one. I liked it because we had to draw it ourselves. And this is the last question I'm going to show you. And it's over to you guys for your revision. Amy is going to play 1 game of snooker and 1 game of billiards. The probability that she will win a game of snooker is 3/4. As we can see here, that means the probability that she does not win. Notice how it's cleverly worded. Doesn't win. Could be a draw or a loser. Okay? You either win or you don't win. It's simple. The probability that she will win a game of billiards is 1/3. So this one is going to add up to 1 2/3. And it should say somewhere they don't affect each other. Amy played 1 game of snooker and 1 game of billiards on a number of Fridays. She won both snooker and billiards on 21 Fridays. Sorry, I've jumped a question. Work out the probability that Amy will win exactly 1 game. So we do have to assume that the probabilities are the same. To win 1 game, it's either win, not win, or not win, win. On the top one, 3 over 4 times 2 over 3. It's going to be 6 over 12. On the next one, 1 over 4 times 1 over 3 is going to be 1 over 12. We want this or this, so we add to get 7 over 12 as our answer. Right, next bit that we're actually on now. Amy played 1 game of snooker and 1 game of billiards on a number of Fridays. She won at both snooker and billiards on 21 Fridays. Okay, so 21, win, win. Work out an estimate for the number of Fridays she did not win either game. Very cool question. I'd like to see how many marks this would be. Probably about 4. Okay, so this is called relative frequency. And we're talking about win then win. So let's think about what the probability of win then win is. So the probability of getting a win and then another win is going to be along this branch here. 3 over 4 times 1 over 3. Okay, 3 over 12. 3 over 12, let's now simplify, divide by 3, is 1/4. So, she expects win-win in 1/4 of the games. Okay? So that means a quarter of a games is 21. Okay? So you're basically, the basic question is 21 over what is the same as a quarter? Well, this is times up by 21. So this is going to be times up by 21 to get them the same. So it's going to be 4 times 21, double it again, 42, 84. So 84 is the answer for how many games? Okay, in total. But you're not asked for how many games in total. That's why this question's even cooler. Work out an estimate for the number of Fridays on which she did not win either game. So we're now in another branch of our tree diagram. We're going not win, not win. Bad times there. So it's going to be 1 over 4 times 2 over 3. Okay, so not win, not win. Probability of 1 over 4, sorry it's getting a bit crowded, times 2 over 3, 2 over 12, which is simplified to 1 over 6. So we want 1/6 of 84 because we've said we're estimating we're playing 84 games. So 84 divided by 6 is going to be, well, 60 is 10 times 6. Then you can just add on 6's until you get to it. 4 times 6 is going to be 24. And look, they go together to give 84. So the answer is 14. 14 games. Right, I really like that question. If I was making exam questions, I would try and make one just like that. 14 games is your final answer. So we've built up in difficulty there. At first, we were just looking at single lines on the tree diagram. We moved up to this final question where we had to add, we had to also think of relative frequency. This video was a request, and I hope I've covered everything that my subscriber wanted. And thanks for keeping in contact and letting me know how all the work's going. I really enjoy hearing about all your achievements and how well you're doing, so that's excellent. Right, good luck in your future revision and achieve maths. Goodbye and thanks for watching.